Have you ever really stopped to think about what's going on inside your phone or your computer? I mean, really think about it. Because underneath all the apps you tap and the windows you click, there's this hidden world. It's a complex symphony of invisible layers of software that brings your device to life. So let's dive in and start peeling back those layers.
Seriously, just look at your laptop or your phone for a second. That sleek piece of metal and glass, what actually separates it from being a really expensive paperweight? What gives it its power, its purpose, its whole personality?
Well, the answer is just one word: software. Without it, the most powerful hardware in the world is, completely useless. It's the ghost in the machine. It's the set of instructions that turns a bunch of circuits into a creative studio, an office, or a gateway to the entire world. Okay, this slide right here gives us a map for our whole journey. I want you to think of software like an onion. At the very core, you get the physical hardware, the brains of the operation like the CPU. Wrapped around that is the system software, which is kind of like the manager for the whole thing. And then, on the very outside layer, the part we actually touch and see is the application software. We're going to peel this onion, one layer at a time.
So let's start with that outer layer, the one we all know and use every single day: application software. Basically, these are all of our digital tools.
To put it simply, an application, or, an app, is just a program designed to help you, the user, do something specific. It could be writing an essay, editing a photo, or just scrolling through the internet.
Let's zoom in on a couple of examples here. First up, we've got our productivity tools. You can see things listed like word processors for writing, or spreadsheets for organizing data and crunching numbers. These are really the workhorses of the software world.
And then, of course, you've got the creative tools. We're talking photo editing software to make your pictures pop, video editors to cut together movies, basically all the apps that turn your computer into a little artist studio.
And finally, the diagram points to all the apps we use for fun in connecting with the world. Internet browsers, games, you name it. All of these programs make up that application layer. But for any of this to actually work, it needs a way to talk to the physical hardware. And that is where our next layer comes in.
So, let's peel back that layer of apps and take a look at what's running underneath. Welcome to the engine room of your computer, the system software.
Now, here's the crucial thing to understand. System software isn't for you. It's for the computer. Its entire job is to control and manage the hardware, creating a stable platform so all those application programs can run smoothly on top.
This engine room has a crew of 3 key players. First, there's the operating system. Think of that as the captain of the ship. Then you've got utility programs, which are kind of like the maintenance crew. And finally, you have device drivers, who are the translators. Let's start by meeting the captain. The operating system, or OS, is hands down the most important piece of software on your device. It's the conductor of the entire orchestra.
And wow, this diagram really shows just how much the OS is juggling at once. Just look at all these jobs circling the center. It's managing memory, handling security with logins and passwords, letting you run multiple apps at once, that's multitasking, and even keeping track of all your files. It is the master controller that makes the whole system work together.
So one of its most important jobs is providing what's called the Human-Computer Interface, or HCI. This is literally the bridge between you and the machine. It's how you give commands and see the results, and it usually comes in 2 main flavors.
Now, most of us use what's called a GUI, a graphical user interface, with all its friendly icons and windows. It's super intuitive, right? But it does use up more computer memory. The other option is the CLI, or command line interface. It's incredibly powerful, very efficient, and uses almost no memory, but you have to know the exact text commands to type. One little typo, and you get an error. All right, let's move on to the next part of our engine room crew. Time to meet the background players, the real unsung heroes of your system, utility programs. These are the little programs that help manage, maintain, and control your computer's resources. A lot of the time, they just run in the background, doing these really crucial jobs like checking for viruses, zipping up files to save space, and backing up all your important data. Here's a perfect example of a utility program in action: disk defragmentation. So look at the image on the left. Over time, as you save and delete stuff, the pieces of a single file can get scattered all over the physical disk drive. To read that file, the computer has to jump all over the place, and that really slows things down. The defragmentation utility acts like a librarian for your data. It reorganizes everything, putting all the pieces of each file together in one neat continuous block, just like you see on the right. The result? A much healthier and much faster system.
And finally, in our system software crew, we have the translators, device drivers. I mean, think about it. Your printer, your mouse, your keyboard, they're all made by different companies and they all speak their own unique digital language. A device driver is just a tiny piece of software that acts as an interpreter, translating between the hardware and the operating system so they can actually understand each other. So now you have all these pieces talking, but how does the computer's brain, the processor, listen to all of them at once?
Okay, so we have apps, and we have the system software that runs them. But how can a computer do so many things at once? How can you listen to music while you're writing an email? The answer is this absolutely brilliant process called an interrupt. An interrupt is basically a little tap on the shoulder for the main processor. It's a signal that says, hey, I need your attention for just a split second. The processor pauses whatever it's doing, deals with that request, and then immediately goes right back to its original task. Let's walk through this flowchart for printing. The processor sends a chunk of data to the printer's buffer. That's just a temporary holding area. Now, while the slow printer is busy working on that, the processor is free to go off and do other stuff. As soon as the printer is ready for more data, it sends an interrupt signal, that tap on the shoulder. The processor quickly sends the next chunk of data and then goes back to its other work. This cycle just repeats over and over until the whole document is printed. And this, right here, is the magic trick. By handling thousands of these tiny interruptions every single second, your computer creates this perfect illusion that it's multitasking. It's not actually doing everything at the exact same time, it's just switching between tasks so incredibly fast that it feels simultaneous. It's how we get that smooth, seamless experience we all expect. So the next time you're streaming a movie, downloading a file, and getting notifications all at the same time, just take a moment to think about the layers. Think about that hidden symphony of applications, operating systems, utilities, and interrupts all working in perfect harmony right there beneath your fingertips.